Hi, my name is Ashish. This is the recording for the part 1 of the practical that we did for emergency stopping of the car. So I'm going to explain the code line by line. So here we are importing all the required packages. This one is for scanning for the laser scan, which we use to figure out the time to collision, and the Ackerman drive stamp, that is for sending the message to car so it can start, stop, and other things. And this is the header message for publishing the timestamp. And then we have generated a class where we specify all the required parameters, for example the speed, and for the last trial we set the speed to -1, and for other trials it was less. We started from 0.7 and went over 1 as well when we tried that, but then this cutoff it would start behaving weird, so we had to restrict ourselves up to 1. I think 1.2 was the maximum. So okay, anyways, so speed, then stopping distance we haven't used in this code, so please ignore that. The cutoff, so this is the constant that we modified during different runs. So when the TTC min from the laser scan is below this value, then the car will stop. So, and these are the regular protocols required to start the car, and these are the messages that we are publishing to the ROSBAG files. And so here we are computing two angles from the scan message that is obtained from here. So for the scan message, minimum angle and maximum angle are required to figure out the angle increment. And so this is coming from the scan message, that is the LiDAR's signal, and this is the shortest unit or the angle which is used by LiDAR to measure the distances. So first the angles, so it is just a regular array based on the increment and create so many numbers equal to the number of measurements. And then the R dot is calculated, so that's the rate of change of all vectors. So it's a list of multiple values, and using all the ranges from the scan messages, then all TTCs are calculated, and from that information we find out the minimum TTC, so time to collision, that we publish, as well as we publish the cutoff that we have specified here. And then we are just printing the messages on the screen for diagnostic. And once the script is running in a loop, it runs in a loop using this ROSPy spin command. So once it is running in loop, and every time the laser scans and it measures all the TTCs, and the minimum TTC value, if it is less than the cutoff value that we specified here, so as soon as the minimum TTC value goes below that, then the car stops. Otherwise it doesn't hit this condition, it just keeps on running. And yeah, if it meets the first condition, meaning the value is less than cutoff, then we send a message to the car and set its speed to 0, so that way the car stops. Thank you.